In this video, we're going to be doing a Boyle's Law experiment using a gauge that records and registers pressure as well as temperature. And so the top value that we see here is pressure in kilopascals. It's hard to read the symbol at the top, but you should be able to clearly see the numbers. And there's going to be some fluctuations as things change. There's a current. You may be able to hear some noise in the background. That's the vent going on. And the lower number is 26.19, and that would be the temperature in degrees Celsius. And so the correlation with Boyle's law is between pressure and volume, and it's what is known as an indirect relationship or an inverse relationship, meaning when one goes up, the other will go down. So, for example, they should be proportional as well and set to a constant. And so, for example, if I have a pressure and if I double my pressure, I really do the opposite. I cut that in half for the volume. Or if I take my volume and I multiply my volume by 10, I really reduce my pressure by 1/10. And so we should be able to see some correlated values. So right now it's hard to read. I'll be letting you know where these measurements are, and you can fill in your data tables to do the work. But right now we are at a volume of 30 on the actual tube. But what we have to consider is if you look at all the other parts of the tube, all this extra area, there's about 6 more milliliters in here. So I'm going to go through from 20 all the way to 40, but really we have to add 6 milliliters to each of those when we do our calculations, because we have to incorporate the extra volume that's in that tube. So for example, at 30, it's really at 36. So when you do your calculation, the 30 really means 36. 20 would mean 26, 40 would mean 46, 25 is really going to be 31, and then 35 is going to be 41. So there's our first reading, and notice there is some fluctuation. We've kind of gone up and down. If you take a range of those values, it really doesn't matter exactly what number you're going to get. We're going to try to get something as close as we can that's consistent. We'll let it basically become standard and steady, and then kind of calibrate itself. So if we just look at that right now and we look at our first number, notice now we have a pressure of 92.91 or 93. Again, you don't have to be exact here, but just pick a number in that range. So notice how it was 92.89, then it was 92.94, 92.92. Find a number that's happy in there. Okay, notice the temperature, 25.89. We were at 26 point something a few minutes ago, and that could be just because I moved some stuff around. We'll notice that there's going to be some temperature changes, but we want to make sure that it gets back to that standard. So the key thing, we need to set until the temperature is about 25.86. And so we want to consider Boyle's law, again, is only a pressure-volume relationship with no, basically we're considering temperature to be standard. We're also considering the number of particles to be standard, and they're just basically changing in this area here and being squished by the syringe. So I'm going to change this, and we're going to go down. We're going to go like one part at a time, and we're going to go down to 20, and we're going to record what changes we see. And again, we have to wait. So I have to hold this here for a moment, and we have to wait until we get to that again at about 25.9. So there we are, about 25.9 again is the temperature. As long as you're in that range, we are good to go. And so we can take our first recording. Notice we're kind of steady. We're at about 128.1, 128.05, 128.2. We are somewhere in that range. So again, find a value that you want to work with. Again, in that range, we're at about the right temperature. We've calibrated or basically got it steady again. And again, our pressure somewhere in the 128.2 something range. So you should be in the 100th point or the 100th position if you want. You can actually round to the 10th place. It might be a little bit easier for your math. Just to keep it simple, round to the 10th place. So for example, 128.8, 128.9, that would be good to go. All right, so that was for the 20 value, which really is 26. All right, we're gonna go to 25. So we've changed the volume to 25, so my volume has gone up. My pressure, in theory, should go down. Remember, this is an inverse proportion, and it should go, again, proportionally. So if I, decrease by a factor of 2, I should increase the other by a factor of 2. Notice, again, we're pretty close to our temperature, 25.7. Give it another few seconds here to see if it goes up to 25.8, which is about where we were. One of the problems is holding the syringe steady. And we want to make sure that we do try to get it as steady as possible. We want to get in that range and be close as we can just to have some consistency here. So it doesn't look like it's changing too much. Again, we're a little bit lower in temperature, but again, in the scope of things, we were at 25.8 down to 25.6. Not a really big difference as far as the temperature's concerned, but it's been pretty steady right there. So we can hold that at, again, this is our 25 sample, which is really going to be 31 because we have to add that extra 6 milliliters in there. So we got about 109.8, 109.9. We already started, we should already have our data for 30. That's where we started. So we're going to skip to 35. I have to pull up on the syringe, and we're going to get to 35. Just a little more effort on my part, 2 hands. Notice the volume went way up, and notice my pressure dropped way down. So we went down to the 70s where I was at 100. So I just want to make sure I'm lined up at about 35 and not pulling it too far because it is slipping a little bit. And again, we want to get that temperature back to about the 25.6 range, 25.7 range. There's going to be a little leeway there. And again, it's not going to be as specific, but again, we increased our volume, so our pressure should decrease, and it should be a constant value. When we plug all these in and you do the math, you should see that your values are pretty close. So 25, if we round that to 25.5, it's about as close as we're going to get. It's not perfect. We'd have to wait here for a little bit longer to let it calibrate, but we don't want to make the full day of this. So we can go with, if we look at it, about 79.6 if we round up, because it's going back and forth between 5.8, 5.9, 6.1. So let's go with 79.5. And then finally for my last one, I'm going to pull out even more to 40. And we notice again that the volume again has gotten bigger. Volume's gone up to 40. Again, my fingers are in the way there, but I'm right at that 40 mark. And my pressure went down. Volume goes up, pressure goes down. So we're pretty close to that temperature. Again, the temperature has been going a little down just because, again, we've changed it, manipulated it, played around with it a little bit. There could be a little leakage, but for the most part, it's pretty on tap, a little bit lower than what it was. But we're going to go with it for the sake of this activity. And if we notice, we're at about 70.3. Okay, 70.31, 35, 31, 30. We'll go with 70.3 for our value that matches up with the 40. So again, just to show you this a little bit different, again, if I bring this down and if I decrease my volume, then my pressure should go way up. Notice I go way down, and the farthest I can go down is to the 20, and now I'm back up. Volume went down, pressure went back up. So make sure you go through, if you need to watch this video again so you can record all the data points and listen to what we were talking about. You have 5 data points. We started at 30, then I went down and I did the 20, I did the 25, came up, did the 35, and did the 40. And then we have to remember that each of those, when you do your calculations, have an extra 6 milliliters added to that because of this additional tubing that we need to incorporate, because that is part of the volume with this sensor. So take this, fill out your data table, do your calculations, and you should be able to answer the rest of the questions based on that. This has been Mr. Gardner with Regents Chemistry, and we look forward to seeing your success on this activity.